The TypeState pattern encodes state into type information. This is useful because, as we showed last time, this information exists when you write the program, but not when you run it. This lets us enforce domain logic, that is, how we map our code to real-world problems, with minimal overhead. Let's imagine a simplified pull request process. Once a pull request is open, it can be approved or rejected. Multiple people can approve it, but if anyone rejects it, even after it's approved, it can no longer be merged. As long as the pull request is in the approved state, then it can be merged. Let's try to model this in a traditional, bad way. First, we'll create a status enum that can be open, approved, rejected, or merged. For the purpose of our example, the pull request type will have a status, but we'll ignore any other data you might want to put on there for now. Our pull request struct has three methods: approve, reject, and merge. A PR can be approved if the status is open or approved. If the status was not one of those, then we'll need to return an error to say that the status could not be changed. Similarly, our reject method will work if the status is open or approved, but not if the PR has been merged. In this case, I've allowed you to reject a rejected PR because it didn't make sense to me that this would be an error, even though it's not strictly part of our process. Finally, our merge method only works if the PR is in the approved status, otherwise it will return an error. We've written up our three state change operations, but we've had to write a lot of branching logic into each method to check that the operation is only being run on a PR in a valid state. To show how complex this gets, I'm listing here the test for every valid state change to make sure that they are successful, and the test for every invalid state change to make sure they're not. But what if instead of a pull request with a status, we represent that status in the pull request type? In this case, we have a separate pull request struct for each state the pull request can be in: open, approved, rejected, merged. Now we can implement each struct separately. In pull request open, we can add the approve and reject methods, and there's no need for branching or errors because we already know the pull request is in a valid state. Similarly, we can implement the pull request approved methods, and again, there's no need for branching given our simple logic. What's really cool about this though is that we don't need to check the state and return a result because it's simply not possible to make an invalid change. The merge method, for example, only exists on pull request approved. You can't merge a rejected pull request because pull request rejected doesn't have the necessary method. This also means we don't have to write tests for invalid state changes because those methods do not exist on invalid types. One downside to this method of doing TypeState is that if our pull request structs have lots of data associated with them, data we've conveniently been skipping over for these examples, you'll have to repeatedly define that data for every type. Heaven forbid you want to change something like the author value from a string to an author new type, you'll have to change it everywhere. Luckily, we can improve this pattern with generics. First, we'll create a trait for our state. This is just to restrict our pull request generic later. We'll use unit structs to represent our state and implement the trait for each of them. We're going to go back to having a single type for our pull request on which we'll keep all the relevant data, but it's generic. The generic type S is restricted to pull request state. Now, importantly, when we create a generic type, we need to use the generic parameter somewhere inside it. What's cool though is that we could, if we needed to, attach state-specific fields to the state structs instead of to the pull request. Moving on, I've created a constructor to open a new pull request, and so long as this is the only method called open, there's no ambiguity, so we don't need to specify the generic to use it. We can now implement our state-specific state changes on only the pull requests that are currently in the right state. For the open variant of our pull request, we can approve or reject them. As with the previous version, there's no branching as we already know that we're in the correct state, so we can move the data and return the new type. Now, you might be thinking, can't we just spread the old pull request into the new one? They're both pull request types. Unfortunately, the generic means that the concrete types are different and Rust won't allow us to just spread one into the other. One way to mitigate the extra work this might create is to group properties into subtypes that could be moved more easily. Our approved variant can be approved by more people, be rejected, or be merged. As with our previous implementation of the pattern, rejected and merged pull requests cannot have their status changed, so we don't need to add any methods to these types. The obvious downside to the pattern, at least in Rust, is having to copy each property across manually. However, you only have to write these methods once, but the benefits just keep giving. Utilizing the TypeState pattern requires writing a bit more code initially, but that code has fewer branches, fewer or in this case no potential error states, and everything is logically subdivided, making maintaining the code more trivial. It's almost always going to be better to take a small upfront cost for cheaper, easier to use code in the long run. If you enjoyed this video, don't forget to like and subscribe. If you really like the video, you can now become a member of the channel or join the Patreon, which I dropped the price on to match YouTube. Next time, we're going to look at how to write fluent APIs. Hopefully, I'll see you then.